This work is entitled Determination of Fracture Toughness in Plain Concrete Specimens by R. Kerr. Experimental tests and computational algorithm are implemented to investigate crack growth phenomena in CO.7 concrete. Firstly, three-point bending tests are carried out on normalized prismatic specimens notched laterally. Then, computational calculation was developed to calculate the concrete toughness on the basis of our curve method, in order to determine the toughness of CO.7 concrete. Prismatic specimens were notched laterally. Figure 1 shows the geometry and dimensions for used specimens. Figure 2 offers details of the shape and geometry of notch. In order to measure the crack mouth opening displacement for the SENV specimens during the three-point bending test, we have used the assembly presented by Figure 3. This figure shows the load evolution as function of the CMOD for 4 different notch lengths. Each of these curves begins with an elastic linear part, followed by a continuous remoteness of the real curve to the ideal line load displacement. Note well that the evolution of cracking goes always through 3 stages. If delta equals 0, the crack propagation is stopped. If the delta ranges between 0 and critical delta we can say that the crack propagation is stable. If the delta A is higher than critical delta A, the crack propagation is unstable. The crack propagates mechanism consists of 2 propagation stages, 1 stable propagation stage while the load is lower than P max. 2 unstable propagation stage. The stage of unstable propagation is more important than the stable propagation stage. The R curves give almost the same KIC and the same maximum crack length for the various notch lengths.